name is Harsh and today we are going to discuss the fourth problem from CP-31 sheet by TLE Eliminators under the 1100 rating range. So let's move on to this sheet, CP-31 sheet by TLE Eliminators. You can see the 1100 rating parameter is clicked and here is a clickable link to your fourth problem. So let's go to the problem. So name of the problem is Yarik and Array. So a subarray is a continuous part of an array. Yarik recently found an array A of n elements and became very interested in finding the maximum sum of a non-empty subarray. However, Yarik does not like consecutive integers with the same parity. So the subarray he chooses must have alternating parities for adjacent elements. For example, if the subarray is 1 to 3, it is acceptable, but subarray like 1 to 4 is not acceptable, as you can see that this subarray has adjacent elements that are not of same parity. What do we mean by elements with same parity? Sorry, that are not of alternating parities. What do we actually mean by element of same parities? By elements of same parity, we mean that the numbers when divided by 2 gives you same remainder. That is basically either both are even or both are odd, then we say that numbers are of same parity. Now they have told you that they want to choose the subarray in which the adjacent elements have alternating parities and not the same parity. But you can look over here, this subarray is not acceptable. Why? Because this has element 2 and 4. They are adjacent and they are of same parity. This is something that is not allowed. So you need to help Yarik by finding the maximum sum of such a subarray. So in the input you have the number of test cases, the size of the array and all the array elements, and it's mentioned that sum of n over all the test cases does not exceed 2 into 10 power 5. So you need to output a single integer, that is the answer to the problem. So let's understand the problem with the help of one of the test cases. Let's suppose we take up this test case 5, 1, 2, 3, 4, 5. Okay. So, the size of the array is 5 and the elements are 1, 2, 3, 4, and 5. Okay. Now, we have to choose the subarray with the maximum sum. Tell me. You chose the first element as 1, you decided to choose the first element as 1. Okay. When you come to 2, can you take it along with 1? Now what is the condition? The condition is that it should be of different parity than the previous element. Okay. So, will you take this 2? Will you take this 2? The answer is yes, you will take this because it is of alternating parity as comparison to 1, since 1 is odd and 2 is even. So you chose this subarray. Okay. Now you come to 3. Will you be able to take 3 in this particular subarray? The answer is yes, you will be able to do so. So you will take now this subarray. Similarly, you will be able to take 4 as well, since 4 and 3 are of alternating parity. So you extend your subarray more, and you will be able to take 5 as well. So you will take this 5 and your subarray will become this. And the sum of this subarray is equal to 15. So, and 15 is the maximum sum possible. So for this particular test case, 15 will be your answer. So I hope you all understood the question, what actually the question is. Now before proceeding for the solution, can anyone tell me, like, can you guess what is the expected time complexity for this question? If you look up, the size of the array is of the order of 10 power 5, isn't it? So you can say that any solution that works in big O of n log n or big O of n or big O of n square root n, this will definitely pass the constraints. But if you have a solution that is working in big O of n square or something like this is something that is not acceptable, isn't it? So we have to design a solution that works well within this range. Now one of the possible solutions for this question is that you just iterate over all the possible subarrays and take the maximum sum of all. But if you are doing so, do you all agree that time complexity in that case will be big of n square? Because what you will be doing, you will be just writing two for loops for int I equals to 0, I lesser than n, I plus plus, and for int j equals to I, j lesser than n, j plus plus. So you know that the subarray that is containing the elements from I till j is a set of is a unique subarray, and you will see that whether you can take that particular subarray or not. This is something that you will need to do, isn't it? So it will definitely give you TLE. So you can't think of doing something like this. You have to think of something different. So what we can do? Okay, tell me one thing. If I tell you that you have the numbers as 1, 2, 3, 4, 5, as we discussed in one of the test cases, we had these numbers. If I tell you that I have this subarray that is having a sum of 1, and I go to a new element, and I want to check what are the two possible options I have. First of all, tell me. Two possible options are that either, the first option is that either I include 2 in the previous subarray, or the second option is that I start my new subarray from 2. These are the two possible options I have, right? Now when I will opt for these options, see, I will not always have these two options. When I will not have these two options, when I will not have this particular option, tell me. I will not have the first option when? So first option will not be there when the current element is not of the alternating parity as the previous one. So let's suppose you would have had numbers like 4, 2, 3, 4, 5, and you had this particular subarray initially. Now even if you want this 2 to include within this particular subarray, you will not be able to do that, because it's mentioned in the question that in the subarray the adjacent element should be of different parity, right? Adjacent element should be of different parity, and that condition would not be met over here. So you will not be able to do that. So these are the two options you have, and we saw that when we will not have two options and when we will have only one option. Now when we have only one option, that case is simple, right? Because we will just start our new subarray from that particular element. But the question is, when we have two options, what we should opt for? And the motivation for this comes from Cadence algorithm. This question is completely based on this algorithm only, along with an extra condition of alternating parity. And it's very logical. Let me tell you. If I tell you that you have some subarray over here, you have choose some subarray over here, and this is some element that you want to choose now. Okay? Let's suppose some of these elements over here is -2. Now just think a bit and tell me, will you ever try to include this particular element AJ in this subarray? Tell me. If this sum is -2, and let's suppose this value, I am taking a value of AJ as 8, will you ever try to include this A in this subarray? Because if you do that, can I say that my sum will become 8 minus 2, that is 6, and 8, that was the impact of this particular number AJ, got reduced. And if you would have opted for the second option, that is, you would have started your new subarray from this particular element 8, you would have got 8 as your sum. So which one is better, this one or this one? Definitely the second one, right? So whenever the sum of the elements of the previous subarray is lesser than whatever sum you have right now, not lesser, actually it's actually negative. If you are standing at an element and the sum of the elements from the previous subarray is actually negative, so you will never try to add this particular element, or you will never try to extend the previous subarray and include this particular element. And the reason is that if you do so, the negative sum of the previous subarray will actually lower down the impact or the positive impact of your current number. This is actually the logic behind this, and this is known as Kadeen's algorithm. So this is how you are going to solve your question, that every time when you have a subarray and you come to an element and this sum is actually equal to 0, this sum is actually lesser than 0, so you will simply make your sum as 0 and you will say that from this particular element I will start my new subarray. Okay, so this is the basic logic. Now how will you check that whether this particular number and the previous number is of alternating parity or not? How will you check that? See, before doing that, it is not always you have to check that. Let me tell you why. If I tell you that this is my subarray, so this subarray will have some starting index, right? This subarray will have some starting index. Let me tell you that this starting index is I and the current element index is j. Okay. Now, if your subarray starts from your current element, then do you need to check the alternating parity condition with the previous element? The answer is no, right? And how will you do that? If the value of I is lesser than j, if this is the case, this signifies that you are trying to include the current element in the previous subarray, isn't it? In that case, you will check the condition of alternating parity. But if this is not so, that is I is, let's suppose, equal to j, this means that your current element is where the new subarray is starting, and in that case you don't need to check the condition of alternating parity. I hope it is clear. Now how will you check that whether the numbers are of different parity or not? Let me tell you. So what you want to check? You want to check that whether the numbers are even or odd, or even. That is, either the previous number is odd and the current number is even, or the previous number is even and the current number is odd. Then only we can say that they are of different parity. Otherwise, if both are odd or both are even, we say that numbers are not of different parity, right? Now how you can actually do this? How you can actually check this? So the method that we are going to use, it's a very helpful method, and this is derived by writing the binary representation of a number. Let me tell you. If I tell you that a number is even, so it is always that the last bit of the number is 0. Whatever in the previous bits, that does not matter. The last bit of the number is 0. Similarly, if I tell you that a number is odd, then the last bit of the number is 1, no matter what the previous bits are. So last bit is always 1. Okay. Now if I simply XOR these two numbers, that is, one of the numbers is even and one of the numbers is odd, if I simply XOR these two numbers, so no matter what I am obtaining over here, the last bit will always be 1. And see, if two numbers were even, and I would have XORed these two numbers, I would have obtained the last bit as 0. Similarly, if the two numbers were odd, and I would have XORed these two numbers, the last bit again would have been 0, right? Because 1 XOR 1 is 0, 0 XOR 0 is 0, but 0 XOR 1 is 1. So only when one of the number is even and one of the number is odd, the XOR result obtained when we XOR these two numbers, the last bit contains 1. And how we can check that whether the last bit is 1 or not? We can simply AND the result with this number. That is 1. This is actually the binary representation of 1, right? 1 and all zeros. So only when the last bit is 1, you will get a result as 1. And if the last bit is not 1, the AND result will always be 0. So how we can check that whether the two numbers are of same parity or not? So simply, if your current number is A and the previous number is B, so they are of alternating parity if A XOR B and 1 is actually true. That is, it is a non-zero value. Only then we can confirm that okay, A and B are of different parity or alternating parity. So I hope the logic to solve this question is clear. So let's jump on to the code. Okay. So first of all, we took the number of test cases as input. Then we took the size of the array as input and the array elements as input. Then we initialized our answer to some lowest possible value. So I initialized it with int mean, and we initialized our two variables I and j to 0. So I basically tells you the starting point of your subarray, and j basically points out to the current element. Okay. So I initialized my sum to 0. Now while j is lesser than n, I am just running this while loop. If my sum is lesser than 0, so tell me, will I include my current element in the previous subarray? Will I do that? Never, right? So what I will do, I will just make my sum as 0, and I will tell that okay, I will become j because now this is going to be the starting point of my subarray. Okay. Now, when do we need to check that the current element and the previous element are of different parity or not? Only when we are trying to include this current element in the previous subarray, right? So only when I is lesser than j, I will check the parity of the current number and the previous number. So if I is lesser than j, then if v of j XOR v of j minus 1 and 1. So basically this is something that we discussed, how we can check that whether v of j and v of j minus 1 are of different parity or not. So only when this result is true, then only I would be able to add this current element in my sum, or basically the previous subarray. So if this is true, my sum got incremented by v of j. Else, if I am not able to do so, this means that the current element and the previous element are not of alternating parity. In that case, I have to start a new subarray from my current element. In that case, my sum will become equal to the current element, that is v of j, and my start of the subarray will also get initialized by j. And if I was not lesser than j, this means that this is from this current element I am starting my new subarray. In that case, my sum will simply become the current element, that is equal to vj. So every time we are taking max with the answer, so we initialized our answer to int mean, and every time we have a valid subarray, we are taking the sum of that subarray, max of the sum of that subarray with the answer. So answer equals to max of answer comma sum, and we move on to the next element, that is we simply increment our j. At the end, once we are done with this, we simply print out our answer and our job is done. This answer variable now contains the maximum sum of the subarray in which the adjacent elements are of alternating parity. So I hope the code and the logic of the question is clear. So let's discuss the time complexity. So you can look that this loop runs for n, and now this loop runs for n, that is j runs from 0 to n, and inside this you don't have any other loop. All the things are of constant time, right? You only have if else conditions. So this loop actually runs for big O of n, and yeah, that's all. So that you can say that the time complexity is big O of n, isn't it? What's the space complexity? So if you look, we constructed a vector of size n, and rest all are constant variables, right? So we can say that okay, the space complexity is also big O of n, and this will definitely pass the given constraints, right? So I hope you all understood the logic. Thank you.